So this is chapter 4, section 1, number 39. We are trying to find the critical points and to find the absolute max and min of this function. So to find critical points, let me rewrite this. You need to know that this function is really that. And that's box squared because it's not x squared, so therefore it's chain rule. So you bring the 2 in front, it'll be 2 box, take away 1 from the power, times derivative box, which gets us that. Now, I don't need to write the first power because that's implied. So I want to know when this equals 0. So these equal 0 when any of the factors equal 0. So when cosine x equals 0 or minus sine x equals 0. Well, where does cosine equal 0? A lot of places. Pi over 2, 3 pi over 2, 5 pi over 2, and on and on and on. And both directions, plus or minus. And when does the sine equal to 0? Well, that's going to be 0, pi, 2 pi, dot, dot, dot. And all those are positive or negative. So that's unit circle stuff. But our domain is 0 to pi. So we can eliminate anything that's outside of that. And in fact, we can't go negative, so it's only positive. And then 0 to pi, I can eliminate those and the negatives there. So we have 3 critical points, x equals pi over 2. Now these are not critical points because endpoints can't be critical points. So therefore, we only have 1 critical point, pi over 2. So how do you find the max or min? We know max and mins can only occur at critical points or endpoints. So we find the y value at the endpoints and at our critical point. And we figure out those y values. I can plug in 0. Cosine of 0 is 1. 1 squared is 1. Pi over 2. Cosine of pi over 2 is 0. 0 squared is 0. And pi. Cosine of pi is negative 1. Negative 1 squared is 1. So we have 2 maximum points, 1 and 1, and the minimum is 0. So that is number 39.